Hey everyone, my name's Andrew Ruffin. I'm a senior product manager at AMD that working in the cloud group. We're proud to be part of this digital event and trust you'll find a wealth of information on how to best migrate to, build on, and optimize within Microsoft Azure. I'm here to tell you today more about the essentials for AMD on Azure and how to make the most of your infrastructure choices for general purpose and AI deployments. So let's get started. We'll dive into the AMD details shortly. I want to highlight that Azure Innovate and Azure Migrate and Modernize are two offerings from Azure that can provide you with support to accelerate your Azure and AI adoption. Azure Innovate itself helps you successfully infuse AI into your Azure-based solutions and improves your analytics capabilities on innovative projects using Azure. And then Migrate and Modernize helps you securely and efficiently move to Azure and modernize your applications. I should say that after this talk, if you're ready to get started with an innovation or migration project, go to the website highlighted below. And at AMD, we're actually part of these offerings when we're ready to support your moves to AMD infrastructure on Azure. Of course, on the right side, the whole event is about Azure Essentials. So you're going to learn a lot from this talk, hopefully, and from all the others today and tomorrow. And this will offer you the best practices to elevate the reliability, security, and performance of your cloud and AI investments. So check out the website there below and be sure to watch the rest of the talks tomorrow for more details. So you heard from Ram earlier in the keynote that he's the head of the AMD cloud business. And as part of his team, you heard about the partnership we have with Microsoft and Azure in particular. So I wanted to give you a bit more details about, to set the stage for why you should look at AMD options in your Azure migration. We're going back in history a little bit. We launched our first data center processor, the AMD EPYC CPU, in the cloud first on Azure back in 2019 with that LSV2 storage virtual machine. We followed it soon after with the first high-performance computing VM on Azure, the HB, which actually just retired a few months ago. So we've come a long way since then. In particular, we've executed on 4 different generations, several different processor types, and we now have over 40 unique VM families meeting just about every need you can have on the cloud and on Azure. So we'll continue to do that. You see the arrow going up and to the right after that. We'll see more, hopefully, in the future. So Azure provides you with many, many choices for compute. And I'll admit that when I first started this role, it took me some time to learn all the naming conventions. But there's a basic trick, for the most part, lets you know when AMD is part of your Azure VM. Well, look for the A in the name. Basically, right after the VM family type, the B for burstable, D for general purpose, DC for confidential general purpose, you'll see a lowercase a, which tells you that you're working with an AMD-based VM. I should say there are some exceptions, mostly related to some of the older VMs, like that LSV2 I talked about before, and those H-series VMs in particular, although those have been AMD exclusive for several generations now. So should be pretty straightforward. Some exceptions, but for the most part, look for that A and you'll know where you are. So what this results in is these 40 plus different VM types across the board, as I mentioned. It's a lot to learn, but you now know typically how to find AMD with that lowercase a in the title. Generally speaking, you'll find AMD technology under the hood. But we categorize these to kind of keep it a little bit more simple from general purpose with the D, E, F, and the B for burstable. The confidential computing VMs with the DC and the EC. I will say I'm not going to get into lots of details on confidential computing today, but I know it's certainly a key part of Azure Essentials, and the security aspects are throughout the best practices here. Certainly look to the DC and EC v6 VMs that have just gone into preview. You can request that preview yourself today, and we should see them go live later this year. But those are for the most sensitive workloads when you need extra security, extra memory encryption. AMD has some very unique offerings there today. I should also say that there's confidential AI VMs as well, including the NCC ADS H100. I'll get to there in a sec. The next category over is our high performance computing, or HPC, if you haven't heard that acronym before. Certainly Azure is the leader in HPC in the cloud. We've got a lot of really good users here, as you heard from Ram as well earlier. AMD ourselves uses these VMs to help design the next generation of our EPYC processors. In fact, we just announced incoming preview of the HBV5 VM, which is a custom processor that we created and will be available first on Azure very soon. But yeah, HX, HBV4 are very unique offerings in the cloud that have some of our unique 3D Vcache enabled EPYC processors. So really high scalability for the most technical and demanding workloads you could have. And then we go forward with our accelerated offerings. There's a very wide array of VM types here. I mentioned the NCC ADS H100 v5, which is really the first confidential AI GPU VM available that is enabled by the EPYC processor on that VM. And then certainly we'll talk more about the MI300X VM, which is based on our AMD Instinct product, the fastest ramping product in AMD history, and it was launched first in the cloud on Azure. We have a few other new ones that are going into preview in that section, like the MA35D, which is really focused on video processing, coding, encoding. So take a look at that. And then going forward, we started with storage optimized with the LSV2. We have an LASV3, and stay tuned for more in that category this year. And then last but not least is visualization for virtual desktop infrastructure, for your graphics or gaming workloads. We launched last year the NG ADS V620, which is focused on gaming. We just launched into preview the NV ADS V710 V5. So go take a look at that. That's really tailored towards graphics workloads, classical machine learning. I think you'll find a great deal of usage out of that one. So many different types. I think I even mentioned we just retired one, the HB. Those V4 VMs there on the general purpose side, they've been around for a long time. I'd definitely recommend looking at least V5, but certainly focus on V6, and we'll get into more details on that shortly. Now, all these VMs are great, but can you get them where you need them? The answer is yes. Of course, there are many details under the hood, but within the categories I mentioned, you'll find every type of AMD VM within your preferred larger region. All the specifics of the regions vary, but AMD-based compute can be found in 57 of the 59 regions today. I promise you, I check on a monthly basis. So if you have questions about where you can find where, come check with me, or I'll give you where you should look. But yeah, we're basically everywhere you need to be. So rest assured, if you don't see what you need, you can always reach out and we can try to help. So this event is about mastering Azure and AI adoption. And I wanted to cover here what we can do to help you with your AI deployment on Azure. We see three broad areas of AI deployments to address. First, you need to make room for AI. So we'll show you how that's done with general purpose VMs on Azure. Let's face it, it's unlikely that you'll go straight into uploading your data, your training data, training a model and inferencing on it without making room in your budget first. We know that is a key consideration before you get started. So that's the first step. The second step really is about, hey, maybe you're thinking about mixed workloads, you're looking at enterprise AI applications, and that usually starts with small and medium-sized AI models for inferencing and machine learning. We'll show you how you can get that done with the now consolidated infrastructure you've created in step one. And third, you might be doing this in parallel with the second step. You'll need to look at medium and large AI models, and that's where GPUs come to play. So we'll show you how you can do this with the AMD Instinct MI300X on Azure while still achieving that efficiency within your budget, because we know it's all about fitting within the budget that you have on hand. So with that, we'll start with that first area, making room for AI. And how will we do that? Well, it's with the general purpose V6 VMs that just went GA, generally available on Azure in November. So we have three different families. I'll walk through them, give you some details about what to look for, what to expect when you go test these out yourselves. But start with the D series, the balanced VMs, so the DA V6 family of four different types. They come in 4:1 and 2:1 memory to virtual CPU or vCPU ratios, and they have up to 96 vCPUs per family. So they come with and without local storage. You'll know that by looking for the little d. The little d means you have the local storage on board. Regardless, you have the premium storage capability, which that S indicates, across the board. And Azure's made some great improvements in the storage performance, NVMe storage performance. So big uplifts gen over gen. And most of the customers I work with, they use a heavy amount of the D series because they're great for a large array of workloads, anything from web services, virtual desktop infrastructure, small databases, app servers, and in between. So I think D is where you will start and look for those DA V6 variants. Next, we have the memory optimized families. These come with 8:1 memory to vCPU ratios. So again, up to 96 vCPUs with and without that local storage. So with more memory comes more responsibility, more power to do memory intensive work like in-memory analytics, think Cloudera or Databricks, financial work, relational databases, think SQL Server, think PostgreSQL, and more. So I think the E series is kind of the second most used VMs I have seen thus far in my time here working with Azure at AMD. And last but not least, we have a new addition to the family, our first F series compute optimized VMs. They are basically three flavors. We have the with 4:1, 2:1, and 8:1 memory to vCPU ratios here. I put it in order there. So you have the L is the low memory variant, the M is the higher memory variant. And these are interesting in that instead of a thread, which is what you get, a vCPU is a thread for the D and the E series. For the F series, a vCPU is a full physical core. So these are meant to provide the fastest CPU performance on Azure, and you'll get it when you need it with the F series. If you have software where you pay by the core, you need to get the most out of that license that you pay for, look for the FA v6 family. So we hear a lot about interest in these VMs for scientific simulations, financial risk analysis, and rendering for videos, movies, things like that as well. Lots of demand for these new VMs. I'll talk a little bit more about how that translates into performance going forward. So actually, I'll get straight to it. We've tested these VMs across a wide range of general purpose areas, which I'll show you details next. But to summarize here, we're looking on the left side there first. Compared to the latest generation non-AMD VMs, the DDS-V5, we're seeing on average 22% improved performance and 21% improved performance per dollar you spend with the DADS V6 VM. If you look at that F series I talked about before, picked F in this case, FAS V6, because it has the same memory to vCPU ratio, just the stronger compute in this case. We're seeing 79% improved performance and 48% improved performance per dollar on average across our tests. Obviously, you go test these for yourselves, but I'll get into the details of what we tested shortly. On the right side there, compared to the EDS V5, we're seeing the ADS V6 is showing 25% improved performance and 24% improved performance per dollar across these 7 workloads. So let's look at the details on the next few pages. And of course, we'll continue to provide more third-party testing and information on the benefits these V6 VMs. Don't just take our word for it. Go test it yourself. So I wanted to show you some details about the 7 tests that we did across the board. We kind of standardized in these 7 tests. We're always adding more. I would love your feedback on what maybe could be more useful for you. But we tested across the web tier, media, business applications, and the data tier. So on the web tier, we looked at Nginx for web serving, Redis for web caching. We did video coding and encoding for FFmpeg. We did some application performance with Java, multi-server instance max. And then looking at the data tier, we looked at some TPCH throughput, kind of equivalent to that, derivative to that test, as well as equivalent to derivative to TPCE for SQL Server. And then for open source database, we looked at MySQL, the tproxy test. So these are all testing their performance across the board, which we consider to be general purpose workloads. Certainly there's a lot more infinite things you can do here, but we're looking at what we think are primarily the bread and butter of what we see Azure customers doing with the D, the E, and potentially going forward with the F series VMs. I'll go through the details in this one, and then I'll show you the E and the F after that. On the left side there, we'll just start with Nginx. We see 18% more performance, gen over gen, the DADS V6 compared to the DDS V5. And ultimately, that translates into performance per dollar, which I showed before, and it leads to OpEx savings. So operational expense savings are all about, for the same amount of performance, you can use fewer VMs to do the same thing. And that leads to the ability to reduce your cloud spend for just the VM itself. Doesn't take into account any of the software licensing costs that you might have on top, just the cost to rent the VM. Whether it's pay-as-you-go or reserved instance, this is a great way to think about how to make room for AI in your budget or any other budget you need to save to invest in other areas in Azure that you see fit. So that's Nginx. Redis, similar story, even better actually, 29% more performance on average, 22% cloud OpEx savings. FFmpeg, we're looking at encoding and decoding for video workloads, so 29% more performance on this side, 22% cloud OpEx savings on there. For enterprise applications with this multi-server instance max Java testing, we're seeing 22% more performance and 17% improved cloud OpEx savings. And then the data tier, we know that obviously SQL Server is huge at Microsoft Azure for a reason. TPCH throughput testing here, 27% more performance and 20% cloud OpEx. And this is where the software licensing savings can really come to bear, even above and beyond what you'll save on the VM itself. And then kind of similar story with TPCE. We look across this one, 11% more performance gen over gen here, 9% OpEx savings just for the VM. And last but not least, MySQL very popular, if not the most popular compared. Well, PostgreSQL, MySQL, very similar in that regard in terms of their popularity. Certainly different fan bases. But we look at MySQL for this one with tproc, 18% better performance, 15% better cloud OpEx. So I summarize all of that into the averages I showed you before. And at the bottom of the slide there, I mentioned we tested across multiple VM sizes. We test multiple instances or multiple runs to get consistency. And this is the average of all of that. So if you have detailed questions about certain VM sizes, 8, 16, 32, bigger, larger, smaller, we can help with that. But I want to give you a taste for what we're seeing so far today. I'll show you the EADS v6 picture. This is the same story here, just with improvements for the majority of the tests across the board, and thus more OpEx savings possible for those memory-intensive workloads. And then going forward, we'll look at the F series here. F versus the D, there's no equivalent F series to compare to, so we look at the F to the D with the same memory to vCPU ratio here. But it's clear that Azure put together something pretty special here. When you need the highest compute performance, you'll find it on the FAS v6 and others in the family. For media and web workloads, it's a standout, as you can see. 100% more performance for Nginx, 136% for Redis, FFmpeg, 110%. And for database workloads where you pay per core, the compute power behind FAS v6 can really help you save even more beyond the infrastructure cost alone. So certainly worth looking at. I know we talked about F series will be really interesting for more intense video rendering, scientific simulation, financial risk analysis. So we'll be doing some more testing of those and come up with more information for you. But certainly reach out with your interest in these because we think they're going to be pretty popular. So I wanted to give you an example of how this translates into the making room for AI aspect that we talked about as we entered into this part of the presentation. So let's think about an e-commerce business that has a set budget to run their business on Azure. Say they have $23 million of budget, they spend it all on hosting their online catalog and their purchasing platform on Azure. They have certain foundational compute requirements you see below. Just an example, Redis for web caching on the front end that hits their Java-based application server. They care about operations per second there. And then it hits a backend SQL Server database to help complete the transactions and make sure everything's right on the backend. So you're able to run your business today with that budget, with those compute requirements, but you're under pressure. Your CTO comes to you and says, hey, our competitors are launching these great features with AI-enabled customer support. They're doing better work on recommendations for products they should check out. It's causing them to have more revenue than us, and we're losing market share. So we need to go move quickly to pilot and launch new AI services based on GPU VMs on Azure. We know that can come with some significant cost. And the CTO says, hey, we need to find $1 million in our budget to go do that, to pilot this. He's not giving you more money, though. He or she is asking you to save within your budget. So that's your task. Let's go see what you would need to do. So here's what you might find. So on the left side, we're showing the total number of EDS v5 VMs to meet the performance requirements we set out before for caching for your app server and for your database server. And on the right side, we're showing what it would require to hit the same performance with the AMD-powered EADS v6 VMs. So with the same performance requirements, you would need 1,054 VMs to meet your goals on the left side. That's roughly $22.6 million using pay-as-you-go pricing. And that's basically your whole budget. Hopefully you aren't using pay-as-you-go for your business. I'd highly recommend using reserved instances when you can. That's definitely best practice within Azure to save on costs and make sure you have a predictable spend. But the example here still holds. So on the right side, you look at EADS v6, and it delivers the same throughput across the board at 22% smaller footprint. So you go down from 1,054 VMs to 826 VMs. And that's a 22% lower annual hosting cost. So that's more than the $1 million you need for your pilot. And an additional $3.7 million you can invest in your team. Other Azure services like Azure Fabric it comes to mind. That's quite often very popular these days. Or you can put that into reserve for when your pilot succeeds and you need to scale up. So this is an example where we only looked at the cloud hosting costs, not the software licensing costs, et cetera. Certainly there's an even bigger impact there. Happy to work through that with anyone who's interested. So yeah, the cost savings could be significantly larger than just renting the VM itself. So these kinds of savings are available to everyone who's on Azure today, whether you're on V5s, V4s, or even older VMs. Look at the more modern infrastructure and you'll see that you can have, one, oftentimes just the price could be lower, and two, the performance is higher, and with that lower pricing potentially, the impacts are even greater. So take a look at your Azure usage and let's go crunch the numbers. That was making room for AI. You saw the example there at the very end. Let's talk about the small and medium AI models and additional cost considerations on Azure. So you've already made the decision to consolidate your infrastructure, general purpose infrastructure, on the more modern VMs. And I have a few examples of these more small and medium-sized AI models where you can fit them on more general-purpose infrastructure. I have two examples on the left that are comparing DLRM v2, which is a recommendation engine. We're looking at a mini LM from Microsoft for natural language processing, Google's BERT Large, and Meta's Llama 2. They're at Llama 3 now, but we're looking at these smaller models, for example. So these can be used for many of the generative AI and other key applications that you're looking at for your business. And inferencing happens varying precision. So we're going to note that below from int 8 to bfloat 16 and floating point 32. As you can see, the performance per dollar for the AMD options is leading here on Azure. So I think the ones on the left there are really interesting. It's the HBV4 series. Certainly those are more specialized VMs we talked about with the HPC side of the house. What I think is actually most interesting is on the right-hand side there with BERT Large and Llama 2. If you're looking at just, hey, the D16, 16 vCPU, pretty small VM, I think it's something like $1 an hour or so. You're going to get up to 51% more performance per dollar for that natural language processing capability with BERT Large. And you can do something similar with the Llama 2 7B model, 32% better performance per dollar using an E-series VM. So I think those are really interesting because if you've already made a decision to uplift your general purpose infrastructure, you can also mix in some of these AI workloads in the process and have significant benefits over older infrastructure. So we'll continue to do more testing on this. I want to get the Llama 3s. I know we've got some really good new Phi models from Microsoft that are coming out for the small and medium model. You might hear, I think it's small language models, SLMs. So take a look for more in the future. But I want to give you a taste for what we're seeing here at AMD. So this is about the actual pricing itself, not put performance to the side, just look at the pricing itself. So whether you're pursuing small or medium-sized AI model inferencing, or just trying to run your day-to-day business, it's clear that the AMD option provides price leadership for x86 architecture VMs on Azure. So the same generation, look at the V5s compared to other V5s. We're seeing about 9%, up to 9%, 8.5% less cost than the comparable VMs in the same generation. And this is just the average across the 2 to 96 VM vCPU sizes. So just look at what size you care about, and you'll find on average this cost savings, just savings alone on the front end. Looking ahead to V6, you'll see that this holds as well. The EDS v6 and DDS v6 are in preview, but we see the pricing there is publicly available. Looking at US East, for example, look at your preferred region, your preferred operating system. You'll typically find these cost ratios hold. So right now we're seeing 11.2% lower cost for the V6 E series and 8.5% less for the D series. So this will help you, make room for AI in your budget again, and also help you find more cost and performance benefits for your small language model inferencing. I should say you'll only have a few weeks to take advantage of this once we go live with the event. But for the short term, until the end of March, you can actually find these VMs for Linux-based workloads, which is the majority on Azure today. And for some time now, you'll find an additional 15% discount for those one-year reservations. I talked about earlier, best practice is absolutely to look at your reservations versus pay-as-you-go. Obviously, we know you can't always do reservations. You have to be nimble. But if you can, I would definitely look at these reservations for 1 year, 15% additional savings over the already existing savings. So check this out. You'll see that this is applicable to basically every V6 D and E series. You'll see a mix of some of the V5s in there as well, including some of the confidential VMs, the DC and the EC. as well as a storage VM, the LAS v3. I definitely look at the v6 though, because we'll see, as you saw before, they're offering the best performance that you can get. With this pricing, it makes it a little bit more attractive. Now your AI pilot was successful, you worked with Azure Innovate, and you need to deploy your medium large AI models with GPUs. So let's talk about how you can do that with the AMD Instinct MI300X while achieving that efficiency in your budget. So just like with Epic, AMD launched the Instinct MI300X V5, or the actual MI300X GPU, first on Azure as part of the ND MI300X V5 VM. So this one is meant to offer leading price performance on key frontier AI workloads like OpenAI's GPT-4. So they are really built to solve problems at this frontier level of the AI journey. We know that models are getting more complex and larger as they grow more powerful. We know that porting models and solutions from one platform to another is expensive and time consuming. So to solve these problems, we worked with Azure to launch these VMs, which include 8 of these AMD MI300X GPUs. You can kind of see a little graphical representation of that on the right. If you ever come to any of the Microsoft shows, we often have some of the physical models of this hanging around, so you can see just the heft of the compute you can get and hold it in your hand a little bit. And we've been collaborating with Microsoft for years, even before MI300X launched, to design the best VMs for high-end distributed training and inferencing. So several generations before of the MI series, but this is really the first one that's focused on AI training and inference performance. And so how do they get that kind of performance? Well, these are packed with a lot of high bandwidth memory, HBM. The capacity these have lets you run larger models with faster and with fewer GPUs. So that's it's all about the cost savings there. And then ultimately, with Azure's virtualized services and AMD's open source ROCm software, we're doing whatever we can to make porting seamless so you can get the performance you need right out of the box and get to market faster and compete when your CTO tells you we got to work faster. One other little tidbit is that these VMs were designed to help with Azure's OpenAI service and production workloads. So, if you're using OpenAI service, you likely have MI300X under the hood. Of course, now you can actually go rent them yourselves with the VM itself that's gone GA this past year. So I'll give you some examples of how that HBM capacity, the memory capacity, actually helps. We've been working to optimize these workflows on these MI300X VMs, and you're able to get quality levels that have previously not been achieved through generative AI workloads like image generation. Think about Stable Diffusion, for example. The MI300X VMs and servers are able to upscale images up to 100 megapixels, whereas you're only able to do something like 32 megapixels with competitive VMs like the H100. So I don't have a 100 megapixel picture on this slide. That would probably break my my PC, frankly, but it's an illustrative example of what we were able to do. And then how that really happens really is, if you look at the right side there, you look at these frontier models like Llama 3.1 that has 405 billion parameters. You're able to fit that whole model into one MI300X VM on Azure. That higher precision there, FP16, if you want to have the best precision, you need 2 VMs of the H100 equivalent VMs on Azure to do the same thing. So this really kind of comes down to the ability to do more with less. We know that these VMs are, you have to make sure that you're able to fit them in your budget. And what we're trying to do is make that easier for you. I should say that Meta themselves came out at our October event and said that they use MI300X exclusively for their Llama 405B inferencing across their platform. So you can have that power as well on Azure for yourself. I want to give you the story about the software side, of course. So we're really dedicated to an open approach with the ecosystem, with our open source AI software, ROCm, that helps to get the most out of your AI hardware, like the Instinct MI300X. And we've been working with groups like Hugging Face that have millions of models that are available on their catalog. You can just download them down to your server and get started immediately. And Hugging Face themselves were able to, at first they had 700,000, and then a few months later we had over 1 million models enabled out of the box to run an MI300X. So that's one area you can go to. If you're working at the framework level with PyTorch, we are working to make sure that PyTorch is natively enabled for MI300X, which is, I think, the most popular AI framework today. But certainly we're working across the board with all the other frameworks and parts of the ecosystem, from TensorFlow to JAX and OpenAI's Triton. As you can see, OpenAI themselves are talking about supporting MI300X natively in the upcoming 3.0 Triton release. We have some support today on Triton 2.0 with ROCm 6.2, I believe, but we'll have even more support going forward, working with OpenAI, certainly a leader and a partner with Microsoft in this space. I want to give you a bit more detail. I kind of touched upon the framework level and the like, but let's talk a little bit about what it takes to make sure that if you're already running on other GPUs from NVIDIA, that you can do the same thing on AMD. So at the framework level, just we're working drop-in out-of-the-box support. As I mentioned, PyTorch is a leading leader in this space, but we're working across the board, as you see. If you're if you're sophisticated and you're working at the kernel level, what we're doing is working with custom kernel code that requires, oftentimes will require joint optimization, which we are able to do with our engineering teams, work with you. We have tools like Hipify that helps you convert, port, and optimized CUDA kernels over to run on MI300X and our architecture. So we have done this successfully with many customers and have demonstrated the ability to do this in the past, and will continue to do so going forward. So we've got tools, we're continuing to improve them. And then if you're working at the library level, we have equivalent libraries across the board to help maintain functional capabilities across the board from NVIDIA to AMD. So we're doing a lot of work in this space, more to come, always improving, and want to work with you as well. So if you want to read more, check out the announcement blog post via the QR code you see there on the screen. I checked, it's still valid. And also it's basically the blog post that came out when these VMs went GA last year. So you find all sorts of details on what they can do. Some of the quotes that you see down below are from that blog post and a previous blog post that talked about the preview of these VMs. We went very quickly from preview to GA, and we're rapidly expanding the number of regions we're supporting. So I check the VM availability in the regions pretty often because I want to make sure I know exactly what's where so I can direct customers to the right places to find AMD. And MI300X is currently showing in 16 regions on the pricing page. Certainly go validate that for yourself. If you're not seeing what you need, reach out to your Azure sales teams and or to us at AMD directly. I also say we'll continue to move forward in terms of the hardware and the software. We're on ROCm 6.3.1. As of December, we're rapidly iterating on that. We also announced next generations of the MI series of GPUs coming out on Azure, though. We launched first with MI300X at Azure, and we'll continue to make sure people can get their hands on it, as well as with the software that we offer with ROCm. And then, we'll continue to iterate and move forward with the open source ecosystem from Hugging Face to the actual frameworks. It's just a really key part of what we're trying to do with the open ecosystem to make sure that you can get what you need wherever you need it. And so, I won't read the quotes there. It's basically the same thing about saving time and money by being able to do more with less. And we'll be able to see much more of that going forward with new users day to day. I want to bring it back to why we're all here today, which is Azure Essentials, really. Ultimately, I want you to take what you learned today here about AMD, why you should consider landing your infrastructure on AMD, and take the best practices that my colleagues here at Azure are able to teach you about building a secure and reliable and scalable infrastructure on Azure. The WAF and the CAF, as they say, are great resources. Azure Essentials is a comprehensive place to get what you need to then go build and optimize on Azure. So certainly check out the Azure Essentials toolkit there. You have direct access to experts. You can always reach out to myself. I think you have a great set of resources. I hope you learned a lot today from the Azure teams, from Ram, from Uli, from all the other presentations, and tomorrow as well. Certainly you can always come back to this in the future. If you're not watching live, I hope you have had a good set of learnings. And certainly, as you saw, we have 40 plus VM types, and I only covered about, let's say, probably about like 10 of them. So certainly there's more to do, more to learn. If you have any questions, don't hesitate to reach out. My name again is Andrew Ruffin. You'll find me at andrew.ruffin@amd.com. Feel free to reach out. You can also find me on the Microsoft Community Hub, have a profile there. Also on LinkedIn, you'll find me there, another Microsoft property. So thanks again for the time and hope to talk to you soon.